All right, so tonight we want to chat a little bit about Git and GitHub. So I want to take a quick poll. I thought there was like a poll function in Zoom, but maybe I don't have it turned on. So just throw it in the chat. From 0 to 5, I want to know how comfortable you are and what your own self-assessment of your understanding of Git and GitHub is. So just throw it into the chat. 0 to 5, 0 being, you are completely don't even know what Git and GitHub is, and 5 is like you could be over here on the other side of this microphone teaching this class. All right, 0 to 1, a lot of 2s. Okay, cool. 3 for Git, 2 for GitHub. A couple 3s, can do basics but mess things up still. Cool. All right. I was trying to get a baseline. I think we set up this, quote unquote, advanced study group, but I think most people don't ever get to the advanced point. I don't even know that I would claim that I'm advanced in my daily use. I think that there's a lot of things that are very edge case that we can do with Git and GitHub, but aren't most practical. So, I think there's the, mess things up. I know I've definitely done it before, and I have to find some weird command that I didn't know existed and do some odd things to get back to where I need to be. But I think a lot of times it's just the day-to-day. So to start, I'm just going to go from the beginning then, and we'll see where we get. So Git and GitHub are two separate things. Git is as it says here on their homepage, if I can get on the right screen, there, a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. So Git is the underlying version control system that GitHub uses to keep track of code. I'm not going to go into a lot of the technical details about how Git works because it just gets really low level. But excuse me, Git is a technology that GitHub, that GitLab, and there's some other version control companies out there on the web that you can store your code with for free. And then there's also other version control systems that are not Git. So one that you may hear from time to time is TFS, which is Team Foundation Server, which is by Microsoft. So if you're working in a heavy .NET ecosystem, you might work with Team Foundation Server. I actually hadn't heard of it before. It's not a big thing in the open source community because you have to pay for it. But in any Microsoft ecosystem, it's super powerful. You can do Git on a Team Foundation server. I don't really know how it works. I haven't worked with it enough, but I just wanted to show that there are some other version control systems out there. They're not all Git, but they all have the same end goal in place, which is we want to keep copies of our code from as we work on it, so that if we break something, we can roll it back and say, okay, we know that it worked 2 days ago. It doesn't work now. Everything's broken. I don't know why. So let me just go rewind everything, go back 2 days, and we can start from there again. It's also a way to step through our code as we make those changes. So maybe, and this becomes especially more evident on a team when you have multiple people working on something. You can see commits from each person and see that, okay, well, this person did this, and this person did this, and this person did this, and this person did this. And that's where we're getting incongruencies. So that's not all that I'm going to talk about with Git, just kind of what it is, real quick what it does. It is a system, I guess you could kind of call it a protocol, and how you just work with your code, and there's services that keep your code for you with it. So GitHub is probably the biggest thing that most people associate with version control out there. Biggest thing being it's free, but it's also, I mean, I think they did that grand bit of marketing where, you know, they took the protocol Git, they merged it into their name, and they kind of became the de facto place that people think of to do Git-based version control. So in Git, every person, I guess I can just go to mine, has repositories. Or a repository you can think of like a project. So any of your projects, any encapsulated group of code that you want to keep together. So going through this program, you'll end up with lots of repositories because every lab is a repository. We can see, we scroll down some, we get into when, here's the end of the, or I guess the beginning of the JavaScript curriculum again. When the new curriculum was released, I started going through the beginning again, looking at it. Not sure what all these are, but a lot of code, and each one of these we can go into, and this is what we call our code base. So all the code for that project. So repository is just another word for a project, shortened to repo, R-E-P-O, that people like to say. Another thing that projects typically have, and this becomes a lot more evident when you're working as teams, is branches. So our Flatiron repos typically have 2, maybe 3 branches, a master branch and a solution branch. And sometimes there's work in progress or something else going on, but typically there's 2 branches. And the idea of branches is that I guess we could find a visual. Let's see. Image. Here, I think this one, I don't want a whole bunch of words. I think this one shows it well. This one, there. The idea of branches is that you have your master branch, you know, the one that you want to say, okay, this is the stuff this is the baseline. And then you might have multiple people working on the project. So each person typically will create their own branch for their own feature, or multiple people will be working on a feature, but you know, you want to add a new section to your website, or you want to add, you know, this cool new feature. So you want to make a branch. And what a branch does, it allows you to work on code without affecting the master. And then eventually bring that code and merge it into the master. So it takes the new code that you've written, the code that is on the master branch, even if it's after some other people have changed it, and puts it together into one cohesive unit. Branches, and lots of things you might think are through the command line with Git, but that's not always true. So things like, let's do something here. Let's go here. Netflix FastJSON API. So I don't have access to this repository, this project. You know, Netflix owns it. I have no authorization to make any changes here. I can't make branches. I can't do anything. So if I wanted to work on this is how you contribute to open source typically. You make a fork. So all a fork is taking the code in this current state right here on this master branch and making a copy for myself to work on. So it's going to give me all these options, but let's stick them. And it takes just a moment. And forks have to be done through this GUI, as far as I know. I could be wrong. I guess with anything that I'm saying, it's a possibility that I could be wrong, but I'm fairly confident in everything that I'm saying tonight from all my time using Git and GitHub. But there are edge cases. There's probably some pretty cool ways that you could get these things done. I just don't know them. But so excuse me. Now I have a copy of this code that I have full access to, full authorization to. I can get this code on my local machine. I can change this code. I can do with it what I want. So we can now create branches, find or create a branch. So let's say flat iron branch, we can create that. And there we go. Branches do not need to be made via the GUI, the website. So now we have our copy of our code, and let's start to work with this code. So the reason you wouldn't want to skip the forking and just go right to clone is because then you're gonna eventually, the idea of version control and distributed version control, which is not just version control on your computer, is that you have a copy of your code somewhere other than your computer. So once and we can show this. Let's do this two ways. We'll go through some examples. So let's clone this code. Okay. Okay, so now I have this folder. Should be fast, yeah, fast, JSON, API. So right now, this folder, this code is still looking back at its quote-unquote parent. So if we do git remote origin, git remote, git remote, where is it? There, verbose. So it's still connected to this Netflix parent repo. And with that, when we make changes, so let's see what's in here. I'm just going to open up this in-terminal text editor and look at this README real quick and change something. Let's say, this performance comparison, we actually want it to be H2, the header, and this is just some markdown. So I'm going to save that. Yes. Write it to the same file name. Okay, so now when we look, we'll get to git status. Okay, we see we have a modified file. So, okay, I've got a modified file. So right now, it's cool to have a modified file. I want to add it. First thing I want to do is add it. And what I'm going to be adding it to is the quote-unquote change set. Or you can think of it as a change set, the commit. So look at commits here, there's a list of commits. So each one of these has a bunch of files that are associated with it. So there's a little number here, which actually refers to a much larger number, but that number is going to have code associated with it. So when we do our git add, we're setting up a commit, or we're setting up the files that we want to be a part of a commit. So let's say git add readme. Now, if we do our status, we have changes to be committed. So we have, okay, we've made some changes and we're ready to commit them. So we're ready to take whatever is added right now and actually create a commit, one of these commits that has some description attached to it. So let's to git commit -m for message. Let's say changed. I don't remember what it was, to smaller header. I'll commit that. Okay, so now if we look, everything is looking good. However, we are quote unquote ahead of our remote. The one that's sitting on GitHub server, we're ahead of it by one commit. Use git push to publish your local commit. So one of the benefits of version control is that we can have our code sitting on this remote server on GitHub, so that in the, hopefully not often, but I guess eventually likely, depending on how long you have your hardware, something fails. You don't want to have all of your, quote unquote eggs, all of your code on your local machine. So you want to have it up there on GitHub. Also, you want that because when you're working as a team, you need a single source of truth, some place where everybody can see the most up-to-date code, where we can combine it all together. So right now, if I tried to put this code back on GitHub with git push, I'm going to get an error because I'm not allowed to push this code to Netflix's repo. They're like, no, sorry, Seth, we don't know you. We don't want you messing with our code base. It's cool. It's out there. It's open source. You can play with it. You can download it. You can look at it, but you're not going to make changes without our permission. So what happened is now we would have to create a repo, connect it to this code, and then push it back up. So to just ease the process, if we fork first and then clone, we're cloning a copy that we own. And since we own it, when we make our changes, we can push it up no problem. So if there's something that you just want to play with and look at, you're not worried about keeping a copy of it, yeah, for sure, just go ahead and clone it from the parent. And then you can see the code, you can play with it, you can do it whatever you want with it. But you're going to have more steps to connecting it to a repository than you would if you fork it and clone it down. Forking it also allows for you to maintain a certain connection, to maintain a connection with the parent. So typically, if there's an open source project, let's say we say, oh, this is really cool, but something doesn't work the way I want it to. Let's say, it's just looks really bad, so we're going to fix it, and we fixed it with our H2. Let's actually step back and get rid of that. Okay, so let's get this one real quick. So now we're getting the forked copy. It's up here somewhere. There we go. So make a change. With every file that you've worked on, you want to add. So, I know there's just this one. I can do git add period. And that will add every file right now that is Spotify. And then git commit. Change to readme. Now, we make our push. And with no problem, our change is on GitHub. So when we refresh this, this should be a little bit smaller. So it should go from this side, because the README is what we were changing, to this side. There we go. So we've made a change. Now, when we make changes that fix problems for projects, the idea is that, I guess if we want to, but typically we do, is to contribute that back to the community. You know, when we get something that's open source and work on it and make a change to it that we think makes it better, we want to contribute it back. So we would want to go back, and this is what's happening under the hood whenever you're working on a lab. So if we look, well, we can go through this process, then I'll show it. So we see we're one commit ahead of the master, Netflix master. That's because we've added one change that it doesn't have. So if we go back to this parent, we can do this new pull request option. What that does I'm going to do this from the wrong place. Yeah, we do it from our repo, new pull request. Now that is going to take, so to be clear, from our copy, we start the pull request. That's going to connect us to the Netflix version of this. And then we can say, you know, sometimes people say, you know, we want all pull requests to go to something like dev. We don't want to just have things going straight to master. And then you can pick what we're working with. And it's going to show us everything that's different about what we have and what is on their code. It looks like a lot of things are on the master branch that are on the dev branch at this point in time. But from there is where we could create a pull request. I think one more click won't do it. Yeah. You put in your title and your comment, and you could create a pull request. Now, when we're working on our labs, this is exactly what's happening. When we type learn, submit, all these things are happening. So the process of opening a lab, what's going on is we see this forked from. When we are on a lab, such as, you know, this is the JS Principal Scope Lab, and we open it, what happens is the Learn Code gem is actually going to this parent repository for us on GitHub, because we've authorized the gem and Learn with our GitHub credentials. It goes here, it forks it for us, so it gets it for us, then it clones it down for us all in one step. And then I think it even runs npm install and bundle install if needed. So it takes care of all those things for us. Then when we do learn submit, what's happening is it's creating this pull request for us back to the parent. So if you look at any of the Learn Co student repos that are in the curriculum, you'll see there'll be hundreds of pull requests. This is when people have finished them up and they've submitted them. And you can see what they changed and what code is different and such. So the commit messages are done because that's what Learn does by default. And that's how code ends up getting merged back in. So some cool things that GitHub can do. Where I need to get to. So this is something that I'm working on. Not very often. 3 months ago was the last code. But just the idea of having like this massive index of Slack networks all across the world. So big grand idea. Implementing and getting it started is hard. I've found thousands of Slack networks, but just have to type them all into HTML, and it takes a while. So some cool things that GitHub can do through its integration is right now we have some pull requests open. Oh, looks like I did some sort of demo here before. So I think I have this code. Should have this code. Hold down so we can see this in action. So other things that we can do from the command line, it's branch. It's going to show all of the active branches on our machine. This isn't all of the branches that are in the repository on GitHub. This is just what I have on my machine right now. So looks like I'm in this add slacks branch, which I think should be fine to work with. Let's see. Master from demo. No. Okay. So let's create a branch. So to create a new branch from our command line, do git branch. Let's say flat iron again. Now, I'm not in that branch just yet. So if I do git branch, we see it's still there. Or we see that we're still in the add slacks, but the flat iron branch is there. To get into a branch, you do git checkout, and then the branch that we want flat iron to be in. Now, we haven't synced up with our server at all yet. So at this point, if we go to the code and we go to the branches, we won't see that at all. It hasn't been pushed up. It hasn't been synced up. So everything is kept local until we sync it with our server explicitly. Now, let's just change the README again for an example. Yay, fears. I think that's an emoji. We'll find out. Okay, so I'm just going to push that up. Or I guess I need to git add all, git commit, added celebration, git push. Okay. We see new branch, flat iron, and flat iron. So now we should see, oh, pops up flat iron, less than a minute ago. Okay. Let's do compare and pull. I just want to create the pull request and show some cool things that we can set up. So these aren't here by default. So if as you start working more and hearing more, you hear things like continuous integration and continuous deployment and, you know, code reviews and automated testing and such. And so GitHub and things like GitHub are where a lot of that stuff is kicked off. So I've started a pull request, and this project is set up to have some checks. So we see 3 pending checks. Because I am the administrator on this repository, I can do things that other people can't, but right now, there's some things going on automatically. So there's some continuous integration going on. And what that is there's some tests that are automatically happening right now. So if we hit details, we're going to end up at Travis CI, which is a continuous integration company. We're going to see that some stuff is going on. We see that, you know, we got a pull request and a build, but there's an environment of Node. And right now, on Travis, a server is being set up automatically going to launch my code, it's going to run tests against it, and it's going to automatically report back if they pass or not. Tests that I've written. And this can be part of a pipeline. So you can connect these things. You can say, you know, okay, before I want to add code into, you know, the master branch, I want to run tests on it. I want to make sure all the tests still pass. Kind of like we do with our labs. You know, we want to make sure the tests are passing. Make sure we didn't break anything with our code. So the automated tests run. We have access to them on our local computer, and we're going to run them, or we should run them. But then before we merge, let's actually run them up on the server, make sure, you know, that there isn't another change somewhere that's breaking things. After that, you can have it kick off to say, okay, when a merge is complete after tests have passed, then I want to actually push that code somewhere else and deploy it and do continuous deployment. And then have that code sitting on a server for everyone to see and work with. What else is going on here is that there's an integration with something called Netlify. And I can't remember if these update in real time. No, I guess not. So, well, that one just did. Netlify has automatically taken the code and created a website with it. So we go details, we see what that code looks like. And it does it for every pull request. And that's just another integration that GitHub has. Okay. Other things that are set up are review required. So this is saying at least one approved review is required by reviewers with write access. So every time code is going to be merged in, it's saying somebody who's on the team, quote unquote, and I have a couple people who were helping me with this at one time. So we have a small team of people. So if, you know, one of you came along and said you forked it and you added a whole bunch of sites and you wanted to merge it in, somebody would have to review it and approve it before it was allowed to become part of the project as a check. So you can add reviewers. I'll put Dave on here because I'm going to see him in the morning, because he's probably going to ask, why did you make me a reviewer of this thing? Or he'll ping me on Slack in a minute and ask. But he will, typically, a reviewer would assign themselves and then do their thing. But some things about the integrations that GitHub has. With that, reviewers can, I guess since I'm making the pull request, you can't see it, but there's a way to approve or deny or leave comments. There's a whole review process built in to here. I guess I can look at a different pull request and show that. What's this? Stephanie. So we see review required, and I can add my review. And this happens a lot in every team. And you'll have code reviews all the time, and they're not something to be worried or scared about. I found in my first job that the code review was super informative. Like, it's teaching through a code review, because it's like, oh, hey, you wrote this code? That's cool, but, you know, doing it this way is better, and you know, the way that, or maybe, oh, you wrote it that way, that's a little ambiguous, we'd rather have you write it X, Y, and Z. And it's a great learning spot. And then after a couple of weeks, I started doing code reviews of other people, which was very intimidating and scary, to say the least. You know, when I'm reviewing somebody who's been, you know, got a computer science degree and been doing web development just for 10 years straight, and like they're like, hey, review some code, and I'm critiquing them. And typically it came out, you know, I would ask a question or say, hey, you know, I think that this could be written this way, or this might be better. And they would come back and say, well, you know, that's a good idea, but here's the 3 or 4 or 5 reasons why we do it this way. So that was also still a teaching moment, because I got to challenge my own assumptions and beliefs of what good code was. And it wasn't always me being told that I was wrong. Sometimes it's, hey, good catch, you know, I didn't see that. I think we all, if haven't yet, will experience just having a second set of eyes on some code can catch some small things. So in here, doing code review, you can click and leave review points. So I can say, hey, we don't need a hero section. You can say, start a review. And now here's one. And we can go through all the code and leave review notes. We click review changes. I'm not going to review the changes, but we could do that. And that'll all pop up in the timeline. So it would pop up right here after this October 12th date with all those comments, as long as code blocks of what the code is, of where those comments are attached to. Something else that you'll find as you're working on projects with more and more people is that you'll have conflicts. So what happens here is that we see this branch has conflicts that must be resolved. Conflicts are when, in this case, Stephanie was working on something, and then somebody else was working on something, and it got somebody else's stuff got merged into the master branch. And now Stephanie has some code that she says is ready to merge, but there's a conflict. There's a clash. Something that, GitHub's saying, I don't know what to do here. I need some intervention. So let's see what. So GitHub has this resolve conflicts button that you can use right here on the web. For simpler things, it's very useful. For more complex things, it gets very difficult. There are tools out there that make it much easier. There is built-in conflict, I don't want to say resolution, conflict tools for in Visual Studio Code that a lot of people really like, even if, that's not their editor of choice. They really like that. There are standalone tools, like I use something called Meld, M-E-L-D, because I'm on Linux and I like it just because it's standalone. I do it. It does its own thing. It's very good at that one thing. And there's a bunch of other ones. But what we're seeing here is how GitHub has said, okay, there's a problem. Saying, I see this title, and I see this title. And they both look all right. I don't know which one to use. I have this title and this link. So it's denoted by chevrons, these kind of a divider with equals, and some more chevrons. What this is saying is, here is what's in this branch, this create app views branch. And then down here it's saying, here's what's in master. And that's how you can differentiate which is which. With larger conflicts and larger code blocks, it gets harder to kind of parse what's what. And that's why I typically like other tools, tools that do side-by-side comparisons as opposed to just, I guess, top and bottom, as this would be called. But that's just how Git does it. You can also do this through the command line, which I don't necessarily recommend. I find it very difficult. But some integrations that GitHub allows are really, really cool. Something else that is a very much underused tool that GitHub has is projects. So projects are, this isn't the most developed part of GitHub, but it's actually pretty full-featured, and it integrates really well if used properly. The projects tab on a repo is pretty much, it's a project management tool. So it's like a Kanban board. It's like Trello, if you've ever heard of that. Asana has this style as well as a task style setup. And it's just a way to manage manage the project. So we can say things that we need to do and such. You can assign the tasks. Let's see. What else was I wanting to chat about? There's also here, what is it? So if you look at Devise, which is a Ruby gem, which you may or may not have heard of yet. If you haven't, you will. Like Devise has a really well-developed wiki on their GitHub. And this is where all the Devise documentation lives. Like how-to articles, 128 articles and growing, and they're all in this wiki. So that's another place that things can be kept on GitHub. So GitHub has a lot more power and features than I think a lot of people realize when it comes to using it. Another thing, I think it's a thing. Eventually, you'll probably want to get into your to set up get back to so something that should be done. I think everybody should set up when they first set up a local setup is setting up an SSH key. So typically, GitHub starts like this: clone HTTPS, which is cool, but use SSH is going to be much easier. And the reason is, once you've authenticated your machine with GitHub, and said, this is me because I've passed keys back and forth, and you know it's me. You won't have to enter your login and password every time you do something, you communicate with GitHub. So GitHub is going to assume when you just use an HTTPS link that you're questionable, you're suspect, because you haven't authenticated through SSH keys. Now, doing this is, I believe, relatively straightforward, but you have to follow very specific steps. The SSH GitHub. So there's this page on GitHub. I know there have been many people I've helped with this who just didn't know the process. It is step by step. So you can read about, check your computer for existing keys. It has Mac, Windows, and Linux instructions. So very straightforward in that. Oh, it's going to the different file. Generating them if you don't have them. Then adding a new one to your GitHub account. And once you've gotten through adding yours, you should be good to go. This is a step that I think a lot of people aren't told about, and it's very helpful. Connecting to GitHub with SSH. And those keys live in your settings. And yeah, that's where you would generate one. Like you see, I have ID fingerprints in here. 1, 2. I guess this one, I don't know, for something, but it's never been used, so I'll just get rid of it. This one looks like it was used. That's used in the last 2 weeks, so yeah, this is the one. This is probably the one that I'm using right now because it's green. So yeah, there's lots of cool things in GitHub. It's super powerful. Really looking at the integrations is cool, this marketplace. The things in there, especially because a lot of them are free. So they're fun to play with, like Code Climate, automated code review. I think I actually used that on one of my projects, my Rails project. Let's see. Rails app. Yeah, right here. Code Climate, got this little badge that I put on there. And you click it, you see, oh, has all this info. And you can set up test coverage. I don't think I have any tests. Apparently I have a code smell because I set up a method that has 55 lines of code. And apparently they think 25 is the most that you should have. But it was for a drop down. Like it shows you all the code. It's right here. This is too much. I'm like, no, that's fine because of what. That's really cool tools to automate the process. So going up towards the end of, okay. People, organizations work things out on GitHub and then SSH their servers or cloud. Yes. So like I worked for a company called Wesley in the past. So like our process was, here's our code base. We see, chores, features. Chores are just AKA, or chores are, no, bugs, chores, features, master production. So things get merged into master, and then they would move to Circle CI. Let's see. GitHub. Circle CI is like Travis CI. And then here, automatic builds against tests. It looks like a lot of tests are failing. But then from here, this would get pushed, once it passed, automatically to a test server. That stuff failed. But this would then go to a test server, which would be on the, the cloud. And then if things worked out on the test server, there was this production branch, which would replicate the same process, but things would be moved from master to production. And then from there, those would go through the same testing process. Once they passed, they would get pushed to a different server in the cloud. So organizations definitely do use things like GitHub. You typically won't see their stuff because like this, you see there's a little padlock on it. You couldn't access it or see this repo, pretty sure. Yeah. A lot of companies are using things like GitHub, just in an enterprise level where the code base is private. And then using some sort of automated system to check the code and then to also push the code out to production. The servers, whether be in the cloud or servers that are owned somewhere. But typically, yeah, there's a piece in the middle. Most of these things can be self-hosted in an enterprise fashion. So, if you have a huge code base and you just want it, everybody in your company works in a complex, I almost said compound, complex. You might want to have, your code base sitting in a server, local server, so that, you're not worried about shooting it out to the web and serving it from there. And, people just pull off of that. The TFS server where I work currently is hosted locally. It sits in a server room in a rack that, everybody hits there, and it's just super fast because, we're not worried about pushing and pulling from the internet. So there's different ways depending on the use case and depending on the company. But yeah, people definitely do work things out on GitHub and then have it migrated from there to servers. Any other questions I can answer as we're coming up on the end? I know I didn't touch too much on Git commands in this session. I think there's 2 or 3 recordings of those in the LearnCo video site, student site. So you can check those out. There's also tons of reference on them. I wanted to show a little bit of the GitHub stuff that I think we don't know about or see or use often, especially when we're just staring at the command line and not really clicking around the site. GitHub Pages is also a super powerful thing. So just post static sites with a couple clicks. Didn't have time to really look at that much. But maybe next one of these study groups we can set up a GitHub Pages site and see how that works. Yeah, well, thank you very much. I have, where is it? I should have grabbed it earlier. One last thing before you go. Please, I'm throwing a link into the chat. Take a couple minutes to fill out our short survey. It's for the technical coach team. It's anonymous. It's, I think, 7 questions. I think only one of them you actually have to type in a word. The rest of them are multiple choice. But we're just wanting to get feedback about our study groups so that we can make them better for you guys. That, we're doing things that are beneficial. So, be honest, be open. Like I said, they're anonymous. We want to get the solid, good feedback to do what is best by you guys. And the only way we can do that is if we're told and we know. So thank you for coming out tonight. I appreciate it. Hope you garnered some good interest, some good info, and learned a couple things. And yeah, if you could fill out that survey, that'd be awesome for us all on the team. And yeah, have a good night.